Welcome. This video is on solving systems of equations using the substitution method. Now, what does solving a system of equations mean? Basically, you're looking for a point on a graph where two lines intersect. So if I have two lines and they intersect, which any line should that isn't, any two lines should intersect at a point unless they're parallel. So right there, that's the solution. It's the point where they cross, basically. Now, with that being said, to use substitution, not my favorite method. I like graphing as a method. Using matrices is nice. Elimination, I think, is pretty good. But substitution is probably, in all honesty, my least favorite method. However, some people really like it. It really fits their brain. But so here it is. The idea for the substitution method is that we think of things as having equivalent value. If I have 4 shirts and the total value of those shirts is $40, so $10 a shirt, I could say you could either have $40 or you could have 4 shirts. Now, in your head, you might think, I'd rather have $40 or I'd rather have 4 shirts. In this case, we're going to assume they're worth the same thing. So I could either make a trade of those 4 shirts or I could give $40. Those are my choices. Substitution works the same way. We're going to pick a variable, define it in terms of either a number or another variable, and say, hey, I could just exchange these out, no problem. Simple barter system, I guess. So in this case, I have y is equal to 3x plus 5. But down here, I see that y can be equal to itself, or it could also be equal to 8. So what I can do is rewrite this equation where I just take the equivalent value, and instead of putting y there, I put the 8 there. So this equation becomes this. And the nice thing about this is it allows me to actually solve for the value of x. Now, what did that tell me? Well, it told me that when I have y equal to 8, x is 1. And the important part of that is if I'm doing a graph, so see if I can make this graph look halfway decent, and you're going to say somewhere around here, and I should have gone ahead and drawn the marks out first. 1, 2, 6, 7, 8. So when I have this line, it probably starts around y is equal to, at plus 5, so here, and it goes up 3 over 1, so something like this. I can make it go backwards a little bit. There we go. Now, when y is equal to 8, I actually have a straight line that's a horizontal line that goes straight through here. So as you can see, if I had done a better job of drawing that first line out a little bit further, it would be even more obvious what I was trying to achieve here. See if I can extend it just a little bit. So really at this point right here, which should be, say, 1, right there, that point 1, 8 is actually on the graph. So what it shows me is where they cross. I use the equivalent value of y to tell me where a point was that they cross. It helped me find the other one. So let's continue to go a little bit more, go a little further and see if it makes a little more sense. Now, in this case, y is equal to 7x plus 13. In the one below it, y is equal to negative 2x minus 5. You are given a little bit of choice here. You can solve for any variable that you want as long as you follow appropriate mathematical rules. And then substitute its value in. I'm going to be super lazy and just look at them from, straight ahead. I'm not going to try to be fancy. I see y is equal to 7x plus 13, so I'm just going to write that below here. And now I'm going to use this one as my point of equivalent value. It says that y is equal to the term negative 2x minus 5. So anytime I see y, I can either write y there, which if I just have the first equation won't really help me, or I could write in negative 2x minus 5. So that's what I'm going to do. I'm going to take negative 2x minus 5 and put it in the same spot as this y. So now it's over here. Now I can just, solve basic equations. So I need to add 2x. This isn't the most complicated math in the world, so I'm not over talking it. And divide by 9. And I get x is equal to negative 2. So now I know that the x value of the point where they cross is negative 2. How do I find the other part? Because anytime you have a system solution, you want to have the x and y, right? So now I can just take this and plug it back into, substitute back in. You're not supposed to say plug in anymore, I forgot. Substitute the value for x in either one. I'm actually going to put it back in the second equation because I just feel like it didn't get substituted in the first time, so I felt bad for it is the real reason. I don't know, I have an emotional attachment to it for some reason. It seems weird now that I'm saying it out loud. Don't tell anyone. Negative 2 times negative 2 is positive 4. And y is equal to negative 1. So my point of intersection would be here. And all I had to do was understand that y and negative 2x minus 5, you can just put them in for each other whenever you want, as long as it's defined that way by the problem. So let's go on to the next one. This one is a little bit yuckier, I guess, if that's a thing that could be. Y is equal to negative 5x minus 13. That's what I'm going to use. Anytime, I'm going to be honest and say, anytime a variable is already equal to another thing and the variable is by itself, I'm going to be pretty honest and just say that I'll use that one. I'm lazy is the reality. I don't want to have to move this around before I do anything with it. So I'm just going to say, whenever y exists in the other problem, I'm just going to substitute this in. And it's important for me to do the parentheses here because you'll see that 2 is multiplied by y, which means I need to treat it as if 2 is being multiplied by that entire term. You can't just do 2 times negative 5x and not care for the 13. It's part of it. No term left behind, I guess. So negative x minus 10x minus 26. So I'll combine like terms here. They're on the same side of the equation, so it was just a simple combination of negative 1x minus 10x. You knew this. I don't know why I'm acting like you couldn't figure that out on your own. Divided by negative 11. And apparently negative 2 being part of the answer is a big deal in this universe that I've created for myself because, once again, negative 2 pops up. Now, the nice thing about this one is I can go back and get the other part relatively quickly by just substituting the value for x directly into the original equation. And despite the hideousness of this negative sign, it is there. So it's negative 5 times negative 2, so it should give me positive 10. So y is equal to negative 3. To wrap it up in terms of this problem anyway, you'll just go ahead and make a single point. Negative 2, negative 3. One more, and I think that's it. This is what you get into beast level behavior now. These are a little bit more complicated because it's not easy and it's not nice. The thing here is I'll solve for x, even though it doesn't really matter. You just do what you have to do to make sure that you get to the right answer. So I'll choose this one, and I'm just going to solve for x. Why not? So I've got 4x, or I have 4x, whatever. I'm trying to prevent myself from saying I got as much. It's my personal goal for the year, I guess. Divide by 4. And this one actually works out sort of nicely because they're all divisible by 4. You'll end up with a lot of fractions doing these. Just be aware. So now I'm saying that x is equal to negative y plus 1. So what that means to me is anytime I see x, I could also put negative y plus 1, and it'll be exactly the same. So I'll go up into 5x minus 5y equals negative 15. And, you know, for x here, instead of the $40, I'll do the 4 shirts option and say negative y plus 1. divided by negative 10. Y is equal to 2. Now that I have the y, it's pretty easy to go back and get the x. All I'll need to do in that case is just substitute it in. And I'll substitute it into this one because, I don't know, why not? Doesn't matter which one you substitute it in. 2, and that's the one I feel like substituting. And it's always a good idea when you substitute a number in, whether it's positive or negative, when you're making it for a variable, just put a parentheses around it. Makes it easier to see later what you're trying to do, and you don't just think it's 42. I used to do that all the time. Oh, it's 42. That makes the weird answer. It's because it's not even the question in the first place, so no wonder it didn't work. X is equal to negative 1. So I have these two parts together, so to make my final answer, I will get negative 1 and 2. This one didn't really get into very ugly style problems. Some of them you will have, like I said, a decent amount of, when you're doing your divisions, you'll end up with fractions like 1/3 x plus 2/3 or whatever. But you still treat it the same way. You have to multiply the numbers by the fraction, and it looks a little bit more difficult. There's tons of videos out there that do it. I just wanted to have a nice, concise problem set for you to see. So I hope this gives you some, initial feeling about what a substitution method for systems of equations actually is.